Okay.
Excellent.
All right. So let's continue that conversation. Bill, would you mind introducing yourself to the audience?
Yes, so I'm Bill Schwebel. I lead the Controls Products Group at Johnson Controls. And Johnson Controls is a products and solutions company focused on technologies and solutions for commercial buildings.
Absolutely. All right, so we just finished talking about that life cycle of buildings and understanding this ecosystem that we are now living in. You know, there was a time where we look at a building and we go, okay, we got lighting, we have HVAC, we've probably got some timers someplace controlling some of this stuff. We got some thermostats. We have a lot of mechanical controls. Those mechanical controls started evolving into digital signals so that we can understand and manage the building. And as technology continues to increase, like as Kaishi was talking about, this evolution of technology and software, we're going to see a lot more AI introduced into our industry, whether we know it or not. We're going to start seeing it in things as simple as thermostats to things like entire ecosystems. So how do you see AI revolutionizing the industry that we know as HVACR?
Absolutely. And just building on a little bit of the life cycle notion, if you think of the technologies that we deployed, we basically deployed a technology for each place in the life cycle. So for the design event, the construction event, the installation event, the commissioning event, all of those events had different software, different technologies, different solutions across that life cycle. Now, with artificial intelligence especially, and the data that's coming out throughout the life cycle, AI is proving to be very disruptive. And it's really hard to predict where it's going to come next. So if you look at the past 12 months and what's changed in the landscape around artificial intelligence and the tools that have come to bear and have changed the way we do work, we've already seen massive amounts of changes of the way we address issues in the buildings.
Yeah, I think about, like, say, digital inputs. I know, like, say if I had a structure that had a variety of rooftop units and each of those had temperature thermistors and pressure transducers, you know, one common event that I would have out in the field is if I had a room sensor that had actually had a short in a wire, cut in a wire, something happened to it, is out of range. I was able to grab the address from a unit very close to it, so that would have been in the same occupied airspace. And I could use that address, and I could copy that, and I can put it in replacement of the one that was failed, but that would take time. And then, of course, we'd have to dispatch for a technician to go out. I imagine we can start looking at AI with those same capabilities as looking at incorrect sensors or incorrect inputs to be able to look at other options automatically.
Correct. So if you think about sensorification and the predictability of AI, to be able to predict what that sensor would be telling you and predicting what I call time zero. So you're saying, what should that sensor be telling me? Because typically a sensor, even in a well-sensored building, you're going to have 15, 20% of the sensors are going to be inoperable or not giving you the right data at any time. So having the software actually tell you, this is what I'm expecting to see based on the other conditions, the other sensors. And yes, you're still going to have pieces of equipment that are dependent on that sensor. And if that sensor's failing, as an example, being able to give it artificial data, artificially intelligent derived data, while you're coming back and replacing that sensor, it slows down the need to be as reactive. So one of the issues that we have that AI is addressing is the lack of talent and labor to be able to go change out that sensor.
Right.
So now I can say, rather than doing it today, I can do it the next time I'm doing preventative maintenance, as long as I'm providing good occupant experiences and good efficiency in my equipment.
So it really leads into predictive maintenance as a new role in our industry, because say we've got this structure that we're in right now, and we have, I couldn't even fathom, 10,000 lights in this facility, let's imagine, somewhere in that ballpark. And we have occupancy sensors in a variety of different places. Well, if this building, say we're in the evening, and an occupancy sensor has went bad in an area, the lights typically in the past were not shut off, right? Those lights are going to be continuing to run. But with an AI, it could actually look back at previous run cycles and go, oh, I am this sensor, and I recognize people on this day of the week, this time. There shouldn't be anyone in this facility, and I've not noticed any movement in other sensors that are close. So I think I'm going to go ahead and activate a shutdown of this cycle, and now I can start looking at dispatching. Oh, by the way, we're going to be closed for 2 weeks. I don't need somebody tomorrow. I can actually bring someone in a few days.
In a few days, right?
Wow.
So a lot of maintenance that we've seen in buildings, more of the break fix model. Somebody calls to complain.
That's our industry.
A piece of equipment is malfunctioning, et cetera. Do a call out, and then you have your service levels based on whether the maintenance team is in-house, which is more and more rare, especially having a maintenance team that has the skills to deal with the equipment in the building.
Yeah.
Whether that it's remote call out for somebody that's associated with the building owner, so somebody that's on the maintenance team, but maybe they're servicing 8, 10, 12 buildings now where they used to service one. So you have that time. Or a service provider that comes in from the outside with the expertise to manage that, being able to apply prediction and predictability and understand the degradation of equipment, et cetera. I mean, preventative maintenance used to be change filters, change fluids,
right,
et cetera, annual clean out, annual clean outs or maybe every 6-month clean outs, but not really on the equipment itself and not really on the occupant space. That what is the occupant experiencing? Are you able to predict what is actually happening, not just the machines and the equipment, but what's happening in the occupant space to be able to adapt to meeting the needs of what that space is right now? I mean, this convention center is an example.
Yeah, perfect.
Probably lives 80% of its time empty.
Yeah, exactly.
But when it's full, it's really full. And you look around, I don't know here, but you still have pneumatics in some of these spaces.
Sure we do.
And then how do you apply a system even on top of that? So it's become very cheap and very easy to put something on the top of a building that interplays with all of the other systems in the building and starts to produce that visibility into the data.
You know, you mentioned filters alone. I look at it from a contractor perspective. As a contractor, I could come into a facility this size and I could send a crew to be here for a couple days and change 500 filters, let's just say as an example, versus understanding the airflow in and out of that area where the filter is, tracking and monitoring and knowing that when I have a disruption of content, I have a increase in particulate matter in a space because I have over occupancy or have a significant occupancy, I can actually monitor and track those and build cycles for the predictive management instead of those traditional, we're going to schedule this in an off season and we're going to be here for a few days. We can now actually know how long each of those filters are going to last and determine and even predict when the best replacement time is going to be for those.
That's a perfect example because when you're changing it every 6 months, let's say, you're actually not hitting it right at all.
Yeah,
right?
Exactly.
So you're finding filters that are still very clean and filters that have been plugged and clogged for months.
Yeah,
right?
exactly.
So, being able to predict that and do just in time or, what level of service do I want to provide? What do I care about? You may have a space that you want better filtration, and you have the information and the use changes, right? We talked about this convention center where the use changes so much. It's seasonality, it's level of usage. That is all data that comes back. I mean, think about a car that's shipped in the last 10 years. It tells you when to change the oil.
Yeah, exactly.
And it's variable, right? It doesn't just say, 8,000 mile counter, or I'm gonna change it based on how you use the vehicle, what it senses from the viscosity of the oil, et cetera. That is a sense of what we're seeing now in the building space.
I think about like from the refrigeration perspective and even on the HVAC or in the commercial refrigeration side, as we continue this HFC phase down and we make transition into alternative refrigerants, the cost of refrigerants are going to continue to escalate in traditional refrigerants, especially our higher GWP refrigerants. And so when we start using technology to monitor these systems and actually do predictions of leak rates, it could change the entire way that we look at repairs of HVAC and refrigeration systems, because we can actually now start monitoring pressures and temperatures and start looking at those changes And artificial intelligence can actually start predicting leaks in systems based on previous history, based on current temperature and pressure calculations, and can look at the refrigerant management of a structure. And we might get a call, by the way, I've actually triggered a 0.5% leak rate on system X that we probably should look at within the next 30 days. Or I've triggered a potential leak rate of 3% that really should be looked at in the next 24 hours. And that was unheard of in our industry, because you're right, we were a very reactive industry from the HVAC and refrigeration side. We would get the calls when things were at their worst. And now we start using all of this digital information, artificial intelligence, to actually monitor these systems when we're not there to actually monitor them. That's crazy to think about, but that's the world that we're living in right now.
Yeah, the benefits of instrumenting a system, monitoring a system, when you think you're doing it for one reason. So, for example, with refrigerants, with low GWP refrigerants like A2L refrigerants, that by regulatory mandate have to be monitored.
Exactly.
And that monitoring system now that you put in to do one task can fund and support so many other tasks, because now you're monitoring the system end-to-end basis, on an end-to-end basis. You're cloud connected to that system, and the amount of information that you pull out of that system lets you do so many other different things. So by instrumenting one thing for one purpose, you're actually getting the benefit across the spectrum in ways you can't even predict. So now you've got a situation where I had a 2-hour must respond or somebody on site for a critical environment. Now we can say, hey, I've got such confidence in the service levels of this facility that I need to be, I can be on an emergency only, and then in a predictive mode for everything else. So that lowers my cost. I don't need 24/7 on-site management of that site. And it goes into, you think of like a Walmart, right, with all the refrigeration cases that they have, and the amount of money they lose when they have a refrigeration issue. They essentially have to throw away all that food. And now you've got that reliability, that stability, because you've got that information. You can monitor the system. You can understand, even from the energy grid sort of perspective, what's happening on the energy grid, and you just feel a lot more confident about operating that building with that amount of information and those AI type tools that you can employ to solve very different problems that you didn't even anticipate when you started on the project.
Yeah, you brought up a great point on that refrigerant management side. I myself spent a lot of time on commercial grocery stores, and as we move into more stringent refrigerant management, which if you're in the HVAC and refrigeration industry, we're starting to see much higher requirements for leak repairs, and some of which require follow-up leak verification that adds additional time to the job. With using artificial intelligence and using tracking of these systems, we're now able to detect these leaks so far in advance they never get to the point of hitting those leak rate thresholds that now are going to require additional time invested to the job. Doesn't matter if we fix the job, we are still going to be coming back to verify once we have certain leak rate requirements based on the capacity of the system and what refrigerants. So in doing that, we're very much saving time, which as a contractor, we all know time is money. And so as we see these changes, I anticipate we're going to see a lot more integrations of AI into existing commercial and even residential structures.
Absolutely. And what it does when you're anticipating these issues, you're catching the problems before they become big problems. If you have a catastrophic failure and you notice, the refrigeration case is not cooling anymore, that's a catastrophe, right? So that requires big, expensive repair. You may have to replace the unit, or at least components in the unit, et cetera. Whereas if you caught it early, it could be a minor repair. It's, hey, I can do some leak mitigation. I know I'm going to have to deal with it longer term, but at least I've mitigated. I haven't harmed the equipment, and I've caught this in time. So it minimizes the potential repair cost and the outage, the cost of the outage, et cetera. So you're getting that visibility that was very impossible even a few short years ago. Most of these cases were controlled by electromechanical systems, not even electronic systems, that could produce some data. Now they're managed and controlled by digital systems and cloud-connected systems. So you've gone from electromechanical to a digital-based, cloud-based system in just a matter of years. And the amount of shift and the amount of impact on the workforce and the people that are dependent on that is changing as well. So we've certainly seen it in other industries that have digitized. I think of my laptop and the cloud support that I get from my laptop. I used to see a technician, a IT tech, maybe once a quarter on site. They were always on site. Now, almost 99% of that work is done remotely, and most of it's done without a human.
Scary to think about, isn't it?
Yeah, but it's a necessary issue, right? That's where our world's going because there's just not the talent. So, for example, in Japan, where we look into the future, we can look to what's happening from a demographic standpoint in Japan. There are only 50% of the technicians that we need to install and manage buildings in Japan. So you can imagine what's happening to the construction and maintenance of those buildings, and it's forcing a rapid investment in technology to manage those buildings. And most buildings in Japan are already remotely monitored and remotely managed. It's a matter of course that 100% of the buildings that are deployed are already remote, and they still have the critical labor shortages in that market, and that's going to happen to the rest of the world. We're seeing it in Europe. Certainly, we're starting to see it in North America.
Yeah, that was actually going to be my next question is, it's change. None of us particularly love change, which is something we do. We adapt to the future. We are at some point going to have to embrace artificial intelligence in every aspect of the HVACR industry. And so internationally, how are we in the United States in comparison to other places? Like I said, we know that now Japan is starting to be very forward. Do you see that the United States is grasping this technology? And if not, where do you see any hurdles that we are facing?
Yeah, I think typically you do see advancements in digital technologies happening in other places, but I think from a data perspective and a digitization perspective, because a lot of the cloud-based, AI-based systems are North American-based, we've seen much more embracing of those technologies. We do have fairly open data use capabilities, so you can apply the technologies without a lot of fear. And this, it cuts both ways. But the privacy fears, et cetera, that some, inadvertently could slow the adoption of some technologies, certainly in a safer, more private way. But you see a lot of experimentation. So even programming a legacy proprietary system using a legacy tool and using something like ChatGPT to say, hey, help me program this very proprietary arcane tool, it can actually help you, and it produces pretty decent code. Wow. So those and the more you do it, the better it gets.
Yeah, I think about that whole commissioning side. From the residential perspective, I know myself, I've been working with a variety of different members of the industry to look at what a connected commissioning protocol could look like for a residential application, so that we can understand when we install and we commission a residential, particularly inverter system, and we're wanting to make sure it is performing to its peak. What type of technology can we introduce that could evaluate the system, use the inputs, use the outputs, make sure that it is performing in its parameter, but also use things like artificial intelligence to go, okay, if I'm not in this parameter, where do I even begin? Because artificial intelligence has been using all of this data that we've been feeding for so long. So even in our residential applications, we're starting to use artificial intelligence for design, for the installation with commissioning, as well as servicing. Do you see this moving into more tools and instrumentation as we move forward?
Yeah, absolutely. So one of the issues with the internet is a vast encyclopedia, essentially. And it's only as good as the static search engine. So if you have a problem, you search on the problem, the most popular answer will come up, and it may not be the right answer.
Yeah, exactly.
So, and it typically is not. And you go through pages and pages and pages trying to find the solution to your problem. Well, in an AI-based world, that going through and finding the solution and feeding that back into the tool, feeding that back into the engine, makes it smarter. And you don't have that frustration of seeing a million hits on how to solve this very simple problem, most of which are wrong or irrelevant because they've tagged it, tagged your system in it, and it's not even your system. And I'm sure a lot of you have gone through that frustration in just even automotive maintenance and trying to find your model, your exact device. But now with AI, you can learn about what problem you're trying to solve and really take that input loop versus just an output loop, but taking that input loop into learning and how do you like to do your work? How do you like to look for things? What's the most recent things and most recent problems you had and remembering that for you. So those are some of the powers of the data technologies that take the way you use the tool into account. And that's one of the biggest differences we see in AI-based technologies because it craves that input. It craves that human feedback loop that gets better and better and better and more refined as you use it.
So if we're wanting to learn more, we're wanting to dive deeper into how artificial intelligence is interacting with software, is interacting with building ecosystems, where are places that we can go to with Johnson Controls to take that next step, to be a little bit more informed with these transitions?
Yeah, so education is a big part of this industry. If you think about, if you had to focus on one thing, it would become much more educated. I think that's a big reason why a lot of people are at the AHR show.
Agreed.
It's to get educated, get updated. The technologies here and the solutions here and the software solutions here are very different than they were even 12 months ago at the last AHR in Chicago. And AI was, this future thing. Now AI is being used in all of the tools. So the AI technology. So becoming educated, leveraging the resources, trying things out. So one of the ways that software is developed by learning the problem in the physical world, really understanding what the process flows and what the data flows are around that, and trying things out. ChatGPT, as an example, is a very easy tool to use. Johnson Controls has resources on its website. We've been improving our ability to share that information, build it into our tools. We have a tool called Solution Navigator, which is the way you design your system and order the system, estimate the system, etc. That is continually being updated. So try that tool out and use the resources. I would do LinkedIn following of people like Kaishi Zhang, who spoke before me, who's one of the industry leaders in intelligent automation, both in the industrial space and the building space. So it's following people like Kaishi and seeing what they publish. There's a lot of material, a lot of content that's getting published, and a lot of it's in bite size. That bite size, the sort of way to gain knowledge and feel better and more confident about the technology. I think in any technology shift, and we're certainly in a big one, it's that fear of the unknown is one of the biggest issues. So the more you can get comfortable with the technology, much like a digital native, some of the Gen Zers that are just so in tune, they don't even realize how easily they use technology. It's getting exposed to that and leveraging that and pushing for the chance, if there's a chance to connect your building, push to have it connected. If there's a push to understand, the exposure that could happen in a building that is connected, learn about cybersecurity, and become knowledgeable about those and put the fear away and start to leverage some of the tools.
Very good. Anyone have any questions on introduction of artificial intelligence into our HVACR environment? Yes, sir. That's a great question as well as comment. So the question and comment is related to the integration of basically the technician or contractor on site and the actual controls, because now we're talking about computer integration. We're talking about software. And many of us technicians are not extremely computer literate. We do enough to do what we do. I know for myself, when I came from the field, I had so many new tools that I had to learn on a computer because what I did very well, but it was very limited in base. So for myself, I had to learn enough IT to be dangerous and efficient. And it was a very delicate balance. And so I imagine with artificial intelligence, it eases that opportunity, because in those days, I didn't have a lot of people that I could ask, like, how would I change this input to be able to be this output? With artificial intelligence, I see the ability to go building automation management system. I see that you've detected this sensor. Could you replace input A with input B for me and trigger a work order for my external service contractor to replace this? And I have a signal for a IT interruption. Can we introduce a IT professional to take a look at this software remotely immediately? I see that as being possible.
Absolutely. So the current generation of AI is really focused on large language models and text-based outcomes, and that's what a program is. Mm-hmm. So a lot of work has been done in that area. So if you think about the typical, you may have an engineer that designed and wanted a special program, special design, worked it in, and the people that actually produced the program itself relied on something for some other building, copied and pasted it. So you have the engineer that had a goal, you have the programmer that had, just did a cut and paste. It wasn't even relevant to that building. And now you're in the install and commissioning phase of that building, having to deal with what was the engineer thinking about? What did the programmer actually give me? And none of it's working. And what we're seeing now with the introduction of the AI capabilities, it's being much more tailored to that specific job. And it understands the intent of the engineer. It understands what the programmer was trying to do by copying something that was somewhat irrelevant, and producing that aid, producing that better program. Now the question is, how do you validate that, right? So that does take some skill to say, even when the computer produced it, so the engineer had an idea, the programmer did the program, the AI actually modified it. How do you feed that back and make sure it's working? So that's part of some of the things that we're talking about in the life cycle around that zero engineering, zero commissioning, that actually brings that full loop back so it can learn. So the first few projects that you do may not be perfect, but over time, you're going to get the advantage of that programming. And then what happens is you become disintermediated from those programs. So there'll be a time, probably not in the not too distant future, where we don't even see the code of the program anymore. The sequences, that's all being just done by the machine. So, and it'll be once that becomes reliable enough. And that's when we get into that zero engineering, zero commissioning phase of what we're calling the autonomous building.
It's pretty intriguing. Does that answer your question? Absolutely. Another question. I have actually been spending a lot of time with startup companies that are focusing on residential. And so it's incredibly intriguing to see what we've done with artificial intelligence for residential. So I have seen a company create temperature thermistors and pressure transducers that could be added to existing systems. So existing non-communicating, non-intelligent residential HVAC systems that now integrates the inputs so that an artificial intelligence can monitor the operation, just like on modern inverters where the control board is using its algorithms to manage the system. We're actually using all of these inputs to manage the operation of the HVAC as well as the airflow. So now we're monitoring filters. I just recently talked to a small startup manufacturer that's introducing temperature and pressure sensing into a thermostat that is communicating to the cloud, that is measuring and monitoring your air filter performance, and can actually set you up on a calendar for automated filter ordering off from Amazon. So it's literally adding a temperature thermistor with a pressure sensor at the inlet of the filter ductwork and one at the outlet of the filter, and is monitoring the performance of the filter, creating its own schedule and then automating to your Amazon account for ordering filters. So this is from a aftermarket company introducing technology into existing non-communicating systems. And I'm also seeing modern inverters. I just was blessed to be able to visit the Johnson Controls factory in Norman, Oklahoma, to see where the equipment is moving, and the future of residential HVAC is going to be a lot smarter. We're going to see a lot more communicating equipment that can also use that data from cloud information to be able to regulate the management of your HVAC system, looking at local electric utility cost so that it is running the most when the energy is the least. And so residential is looking at the same design and looking and learning of how to manage a system, because sometimes just those fractional changes could be very significant. If we look at a structure like this, and if I could turn off 500 light bulbs for an hour, that's a big reduction. Even in a residential structure, if I had the ability to know the occupancy of my building, no one's here, I'm going to run a system, but now I've got geo-tracking from an input from my homeowner. I can actually start managing my ecosystem of my residential all from artificial controls, cloud-based controls. And so I've seen introductions in this last year. You're right, you mentioned these last 12 months have been monumental for the way our industry is looking forward from every aspect. And so it's important for us to understand that it doesn't matter where you are, industrial, commercial,
residential. Yeah, I just, the question is around, commercial versus residential. And the consumers over the last 25 years have really benefited from the technology change. It was always the enterprises would get the technology first, and then it would filter down. You could envision, your mom or dad bringing the PC home from work was the first time that you experienced a PC in the home. Now it actually happens the opposite way. More homes and more residential structures are connected than commercial structures. Commercial structures, we're still at the 5 to 10% sort of level of connected buildings. And you don't cross the chasm, so to speak, until you hit that 15% mark. Once you hit that 15% mark, then you see a skyrocketing in technology adoption. We've already achieved that in the residential space. So there's a lot of technology available at very affordable technology, because a lot of the technology is subsidized by the big internet players that want to provide those sensors and provide those capabilities for the home. And we do see some of that technology bleeding into the light commercial space, because a lot of the same control technology, et cetera, can be used in a more complex home or a lighter commercial sense. But the complex buildings and the mid-market buildings have really been starved a little bit. The systems are so complicated that they haven't been integrated. So you have little point solutions and you don't have that integration. So I can do something with a digital intelligent home thermostat that can control all of the systems, understand my filtration, filter replacement cycles, et cetera, understands outside temperature, seasonality, occupancy, et cetera, and provides it all in one place. And we get tremendous efficiency out of those systems. So to a certain extent, as we look at the commercial and industrial space, we're leveraging the learnings and the capabilities that we're seeing in the consumer space. And the same has happened, in other technology areas where the consumers are now benefiting more from the digitization and the technology adoption than even the enterprise commercial spaces are.
Yeah, so we covered quite a bit of how we use automations for predictive maintenance. And so instead of preventative, we're actually using them for preventative in many aspects. So we're looking at especially like the life cycles of refrigerant in refrigerant management, and using artificial intelligence for predictive of refrigerant leaks and for system repairs. So a pretty significant amount of the podcast, we did cover that.
Certainly, and I could just add a little bit from an OEM perspective. Johnson Controls as a manufacturer perspective, we do see the connection to the asset, to the equipment itself, as being key for not only the serviceability and predictive maintenance of the equipment, but for the life cycle of our product life cycle, our portfolio life cycle, and getting that data back and how our equipment is performing in the field and performing across the life cycle is critically important, especially obviously during the warranty period, but even beyond as we look at the whole life cycle. So The fact that we're now getting that real-time data, that live data back at the manufacturer has been a huge boon in our being able to build more reliable, better systems, but also in our product life cycle, development life cycle. So typically you'd look at a 2 to 3, I heard yesterday, 4-year product development life cycle. We're seeing life cycles down to 5 or 6 months now because we have that real-time feedback loop of how the equipment is being used in the field.
All right, if anyone has any other questions, if you could join Bill and I afterwards. We have another podcast coming up. We really appreciate you being here. We're grateful for Johnson Controls. Thank you, sir.
Thank you, Clifton.
And glad that you joined us today.
All right.